In last video, we have discussed Dalton atomic theory. In Dalton atomic theory, we have discussed the main postulates of Dalton atomic theory, merits of Dalton atomic theory, and drawbacks or limitations of Dalton atomic theory. In this video, we are going to discuss the fundamental part, the, the simplest particle of the matter, the smallest particle of matter, that is called atom. Atom is the smallest particle of the matter. We are going to discuss some important points regarding atom. Okay, atom. Atom. It is the first point is it is the smallest particle of matter. It is the smallest particle of matter. Second one, it directly takes part in a chemical reaction. It directly takes part in a chemical reaction. You studied, we studied so many reactions. In that chemical reaction, we write so many molecules. That is, H2 molecule react with O2 molecule to give water in presence of platinum catalyst, or in the presence of, or when we are giving electricity. In the presence of electricity, that is when we apply hydrogen gas and oxygen. When we apply electricity to hydrogen gas and oxygen gas, we will get water. Okay, that is H2 molecule react with O2 to give water molecules. H2 plus O2 gives 2H2O. In this reaction, H2 molecule, actually molecule does not take part in a chemical reaction, but we write H2. Before chemical reaction takes place, H2 molecule split into atoms, because our molecule does not take part in a chemical reaction. Only atom take part in a chemical reaction. Okay, that's why only atom take part in a chemical reaction. Therefore, this molecule split into atom before, that is during chemical reaction. The first process is the splitting or dissociation of molecule into atoms. Then atom taking part in a chemical reaction. That's why we write the next point of atom is to directly take part in a chemical reaction. That is, in chemical reaction or during chemical reaction, any reaction, molecule does not take part in a chemical reaction. That is, they split into atoms. Atom take part in a chemical reaction. Okay. The third point is it may or may not exist in the free states. We know periodic table. In periodic table in detail, we will study in detail in next modules, in coming modules. Okay. But we know that 18 group in periodic table. 18. How many groups are the 18 groups? That is 18 vertical columns and 7 horizontal rows. Horizontal row is called period and vertical column is called groups. 18 groups. Out of 80 groups, the 18th group elements, that is noble gas, helium, neon, krypton, etc. They exist as atoms, not as molecule. They exist as atom, not as molecule. That is, it can exist in the free state. That is, some atoms of the elements in the periodic table can exist in the free state. Noble gas are some examples. Helium, neon, argon, etc. We call it as noble gas. Okay, ordinate gas. They exist in the free state. But we know hydrogen, they exist as H2. O2 atoms exist as O2 molecule, not as hydrogen does not exists as hydrogen atom, it exists as H2, that is hydrogen molecule. O2, oxygen atom does not exist as oxygen atom, it exists as O2 molecule. Nitrogen also does not exist as atoms, it exists as N2 molecule. Okay, that is why we write as it may. It may exist means some atoms of element exist in the free state, may not exist in the free state. Example: hydrogen, oxygen, nitrogen, etc. They will not exist in the free state. Okay, some atom exist in the free states. What's the reason for that? We will study in detail in subsequent coming chapters, coming modules. Okay. Next point is this point. It may or may not exist in the free state means some atom exists in the free state and some atoms does not exist in the free state. Okay. Examples: hydrogen atom, carbon atom, iron atom, gold atom. These are the examples. Okay. Then molecule. What is meant by molecule? It is formed by combination of atoms. It is formed by combination of atoms. That is two hydrogen atoms combined to form H2 molecule. Two hydrogen atom combined to form hydrogen molecule. The same way, two oxygen atom combines to form O2 molecules. Two nitrogen atom combines to form N2 molecules. That is, molecules are formed by combination of atoms. Okay. It does not directly take part in a chemical reaction. It does not directly take part in a chemical reaction. I already told you that molecule does not take part in a chemical reaction. During chemical reaction, molecule first of all split into atoms, then atom take part in a chemical reaction. All molecule can exist in the free state. In the case of atom, what we study, what we have studied, atom may or may not exist in the free state. That is, some atom exist in the free state and some atom not exist in the free state. But here, all molecule can exist in the free state. All molecules, some molecules are more stable, some molecules are unstable, but all molecule can exist in the free state. Okay. Molecule. You know a lot of examples. I've used some example. H2O, CaCO3, calcium carbonate, HNO3 means nitric acid, etc. Okay. Then classification of molecule. Molecules, classification of molecule based on type of atom. Based on type of atom. They are classified into two. Homoatomic molecule. We are going to discuss classification of molecule. First one, based on type of atom. Based on type of atom, they are classified into two. Homoatomic molecule. Homo means same atom. Okay, a molecule which contains same type of atom is called homoatomic molecule. A molecule that contains same type of atom. Example H2. H2 means hydrogen molecule. It is a homoatomic molecule. That means it contains only one atom, that is hydrogen atom. Another example is O2. It contains only oxygen atom, that is two oxygen atom. Another example is O3. Ozone. Ozone day. We celebrate ozone day. Ozone, O3. It contains oxygen only, that is three oxygen atoms. It is an homoatomic molecule. Example, O2. O2 contains oxygen atom only. That is same type of atoms. O2 contains only same type of atom. Okay. O3, it contains same type of atom, that is oxygen atom. H2, some molecule that contains only hydrogen atom, that is same type of atoms. N2, it also homoatomic molecule. Right. Then heteroatomic molecule. Hetero means different. A molecule that contains different type of atoms is called heteroatomic molecule. A molecule that contains different type of atom, same type of atom. If a molecule contains same type of atom, it is called homoatomic molecule. If a molecule contains different type of atom, then that molecule is called heteroatomic molecule. Example H2O. H2O is not a homoatomic molecule because it contains hydrogen and oxygen element. Therefore, H2 is an heteroatomic molecule. That is heteroatomic molecule since they contain hydrogen and oxygen. They are different atoms. Okay, different atoms of elements. Heteroatomic molecule is also called compound. We have already discussed that pure substances are classified into element and compound. What is compound? Pure substance or substance that contain different type of atoms. That is the compound. Actually, heteroatomic molecule sometimes called as compound. For example of heteroatomic molecule H2O. It is an heteroatomic molecule. It also a compound. In the same way, homoatomic molecule is also called, we can call it as elements. Oxygen is an element because it is an oxygen atom. O2 molecule is also an element. Why it is element? It contains only oxygen atom. O3 molecule, it is also an element. It is also an element because it contains oxygen atom. Okay. Example H2O, CaCO3, HNO3, etc. Then classification based on type of atom. Based on type of atom. They are classified into two. Monoatomic molecule. Based on based on number of atom. Based on type of atom we have discussed. Okay. Based on number of atom, they are classified into two. Monoatomic molecule. A molecule which contains only one atom. A molecule which contains one atom. That type of molecule is monoatomic molecule. Example, all metals, noble gas like helium, neon, argon, etc. All metal are monatomic molecule because it contains only one atom. Okay. Diatomic molecule. A molecule which contains two atoms. A molecule which contains two atoms is called diatomic molecule. Example H2O2 and two halogens. Fluorine, chlorine, bromine, iodine, etc. They are diatomic molecules. That is, they contain two atoms. Then polyatomic molecule. A molecule which contains more than two atoms is called polyatomic molecules. Example, ozone, phosphorus. Phosphorus molecule contains P4. That is 4 phosphorus atoms. Sulfur contains 8 sulfur atoms. That is, they are example of polyatomic molecules. That is, molecules are mainly classified into two. First one, based on type of atom. They are classified into homoatomic molecule and heteroatomic molecule. The second one, based on number of atoms. They are classified into monoatomic molecule, diatomic molecule, polyatomic molecule. Okay. Monatomic molecule means it contains only one atom. Diatomic molecule means it contains two atoms. Polyatomic molecule means it contains more than two atoms. The PDF notes of all my video soon available in YouTube. So I think that will help you more. So I will upload soon the PDF notes of all my video. Thank you for watching my video.